Hi, welcome back. So let's see how to create temporal table in SQL Server 2016. So as I said earlier, creating temporal table is very easy. We have to define two date time, two type column, one for the start of the row and another represents the end of the row. These two columns represents the validity of any row. So So to define temporal table, the syntax will remain same. We first define the column as usual and we to create temporal table first we define the columns as usual as we define in ordinary table and later we add two column one valid from and one valid to. These column name can be anything. We have to supply the type date time to and for valid from column we have to pass keyword generated always as row start and for valid to column we have to pass keyword generated always as row end and we also have to supply period for system time to define the validity of the each row, which row is valid from which time to which time. And finally we have to define system versioning on. This will on the versioning immediately on the table and we can also pass the history table name. If we do not supply the history table name, then SQL Server will automatically assign any random name for the history table. So let's see in demo how to work with temporal table. So here I am using SQL Server Management Studio 2017 to connect SQL Server 2016 instance. So let's first drop database temporal table demo if it is already exist in the server. Now let's create database and use this. So here I have created temporal table demo database. So let's first create a temporal table. So as I said earlier, I have specified valid from and valid to two date time two type column. One will be generated as start of the row and another will be generated as end of the row. And I have specified period for system time and pass the valid from and valid to column and I have specified which system versioning on. This will immediately on the versioning on department table. So let's create table department. So on the object explorer we can see on the tables. Here we have created the department table. So the icon for the history table is something different than the usual table. We can see a clock symbol over the department table. If we expand department table we can see a history table is created for the department table with the name MS SQL temporal history for and one arbitrary number provided by SQL Server. And if we see the columns, these are department ID, department name, manager ID, valid from and valid to. So the columns in the history table have same schema as in the actual table. We can see on the history table the column information is same. Here also we have department ID, department name, manager ID, valid from and valid to. One thing we can notice on the history table, we do not have any primary key or on the history table, SQL Server do not specify any constraint or foreign keys. One thing we can notice on the history table, though the column definition is the same, but SQL Server haven't created the primary key on the department ID column. This is valid because on the history table, as we know, it maintains the different version of each row. It is possible that if we change any row multiple times, then multiple entries of same row will be inserted in the history table. So this is the reason SQL Server haven't created any primary key on the department ID. So in this table we have see if we haven't specified the name of history table, then SQL Server will create the history table automatically. So let's first delete the existing department table and let's try new syntax when we can pass the name of the history table. So first we have to off the system versioning to drop the department table. So let's first off the system versioning by altering the department table, and then we can drop both table individually. So let's copy the name of this department history table and drop this. So let's refresh the table. Now we can see there are no table. So this time let's create the same department table with one difference. This time we are passing the name of history table as department history. So let's create. Now refresh the table node and we can see a department table is created. This time the name of history table is the department history. Now let's drop all the table and see how to convert any existing table into temporal table. So suppose we have a user table with the ID, first name, last name and city column, and let's insert few row in the user table. So now let's query user table. So we have 3 rows in the user table. So as I stated earlier, to convert any existing table into temporal table, we have to specify two date time, two type column, and we have to specify period for syntax. So let's add these column into the user table. So if we query now user table, now we can see we have added start date and end date two column, and we have also specified the default date for these two column. So now let's on the system versioning and also specify the name of history table as user history. So now refresh the table node. We can see user table is converted into the system version table or temporal table, and we have user history table having same schema as the user table have. So now let's query both user table and user history table. So now we can see currently in the user table we have 3 rows, and in the user history table we do not have any data because we haven't performed any operation till we have enabled system versioning on user table. So let's first update row 1 and update the last name from Sukla to Kumar Sukla. So let's query user table and user history table. So now we can see in the history table we have the previous version of the row, and on the actual table we have the current name that we have updated. So when user will perform this update operation, what SQL Server has did, it created a one row of the older data into the history table, and the end date is specified when the transaction was begun. Note that these time are in the UTC time. So this indicate that this row is valid till the 2017 8/29 15/24. So let's perform one more operation. Let's update the City of first user to New Delhi. Current value is Gurgaon. So now let's query user and user history table one more time. We can see the second value is inserted in the history table. The current city of the user is updated to New Delhi, and the previous version of row is stored on the history table. We can also see the validity of this row. We can see we have start the transaction at 1526, so the end date of this is as 1526, and here we can also see the start date of this row is 1526. So these two values should be matched because this indicates that this was the older version prior to this one, and first row indicates that these two values are same. End date of the first row and start date of this, these are same because when the validity of this row ends, then validity of second row starts. Now let's try to delete a row from the user table. So let's delete a user with the id 2. Now let's query users and user history table one more time. Now we can see in the current table we do not have user id 2, but in the history table SQL Server has stored the deleted row, and it has specified time 1527 when the delete operation begins. So in this way we can see how SQL Server stored the user operations, that is update or delete information into the history table, and later how we can query the old data or how we can query the data at any given point of time. So let's quickly review what we did in this video. We have created temporal table with specifying the history table name and without specifying the history table name. Later we have converted any existing table into the system version table, and after that we saw how SQL Server stores the user operation, that is update or delete information into the history table. So let's see in upcoming video how to query this user tables data at any given point of time. Thanks.